Hello everyone, my name is Purnachandra, bearing rule number 1795180-249 from Electrical and Electronics Engineering Department. Today my topic is about interfacing of A to D converter. What is ADC, analog to digital converters? Most of the qualities such as temperature, sound, etc. are in analog form. These quantities are represented accurately in analog form but are difficult to process, store, or transmit the analog signal because error gets included easily due to noise. Hence, due to these errors, it is always better to express these qualities in digital form. For the purpose, ADC, analog to digital converter, is necessary. We have many ADC ICs like IC7109, ICL7109, ADC0808, 0809, etc. Here we will only discuss about ADC 8051. Principle 2, analog to digital conversion in ADC. Analog to digital converter uses successive approximation as the conversion technique. The ADC 0808 is a modalistic CMOS complementary metal oxide conductor device with 8-bit analog to digital converter input, 8-channel multiplexer and microprocessor capable control logic. It includes 256 register voltage drivers, a group of analog switches, and successive approximate registers (SAR). As there are 8 analog channels, we can connect to 8 analog inputs to these ICs. Features: inbuilt 8 analog channels with multiplexer. 0 or full-scale adjustment is not required. 0 to 5 volt input voltage range with a single proximity of 5 volt supply. Output is TTL compactable, very high speed, low conversion time, that is 100 microseconds, high frequency, high accuracy, 8-bit resolution, low power consumption, less than 15 milliwatts, easy to interface with all microprocessors, minimum temperature dependence. Here is the block diagram of ADC 0808. You can observe 8 analog inputs, 3-bit addressing, which is a latch or attached to the 8-bit multiplexer along switches. As we can see at the right side, 3-state output latch buffer in which you can get 8-bit output. Pin configuration. As you can see, you can selection of one of the analog input using the address line A, D, A, B, and C. Here, every pin is divided or given input in the form of 0 or 1s. Pin configuration of ADC 0808. Analog input IN0 to IN7, which you can see in the previous slide. Address pins A, B, C, which are pin number 25, 24, and 23 respectively. Reference voltage, which is reference voltage positive as well as negative, which when get termed into input and output. ALE and output enabled. Start SOC and EOC and data bits and D0 to D7. CLK, which defines clock input. Interfacing of ADC 0808 to 8051. As you can see, interfacing can be done in the following way, as shown in the figure. Interfacing of ADC 0808 to 8051. ADC 0808 has 8 input signals. Here, in order to select an input channel, it is essential to send 3-bit address on C, B, and A inputs, as mentioned earlier. The address of the desired channel is sent to the address inputs through port pins P2.0, P2.1, and P2.2. After 15 nanoseconds, the address must be latched. It can be obtained by sending ALE signal after 2.5 microseconds. SOC must be made high and then low to start the conversion. To indicate end of conversion, EOC signal must be activated. The 8051 pins P2.6 and P2.7 are connected to SOC and EOC pins of ADC 0808. After conversion is over, 8-bit digital data is present on D0 to D7 lines. Algorithm to convert this analog signal to digital signal. Select an analog channel by provide bits to A, D, A, B and C. Enable clock, which means giving pulse to the multiplexer. Activate ALE with low to high pulse. Activate SE with a high to low pulse. Start conversion. The conversion will begin on falling edge of the start conversion pulse. Monitor EOC pin. After conversion, this pin goes high. Activate OE with a high to low pulse to read data output of the ADC chip. Program. To program the ADC, you can just copy from it or you can write down. We can move P1 hash 0 OXFF which indicates the P1 port is being initiated into the multiplexer. Again, wait. These are the codes which are required to convert analog signal to digital signal. Thank you.